Hello everyone, welcome to my channel C.S.E-Pathshala. We are studying about machine learning using Python 3, and in this tutorial we will study about exponential chi-square and Rayleigh distribution. So let's start with exponential distribution. It is used for describing time to the next event. For example, a event has been occurred at this moment, and the next time that certainly another event is going to be occurred. So we will consider the throughout time from this event to the next event. For example, we are having a failure right now. If we talk about an event, we just got failed. So unless and until we haven't get succeed for the next time, the duration will be considered for the exponential distribution. It has two parameters. That means one is the scale, that is the inverse of the rate of an event. Okay, it is having a default value of 1. Then the next one is the size. Obviously, that will return the shape of the array. Okay, so let's consider a code. Draw out a sample for exponential distribution with 2.0 scale and a size of 2 cross 3. So let's consider a code and implement it on Jupyter Notebook. Alright, so import NumPy as NP. From NumPy import random, x equal to random dot exponential. Here we are taking exponential method for the exponential distribution, and the arguments we are giving as scale, that is the rate, inverse of rate. We are giving here it as 2, and the size obviously 2 comma 3. That means 2 represents the rows and 3 represents, that means every row consists of 3 elements. Then we are printing its value. So let's save this code and run this code. Alright, so here it is. Okay, so it represents an exponential distribution. Now if you want to visualize exponential distribution, let's consider one more code and implement it here. Okay, so let's see how to plot a graph of it. Import NumPy as NP. From NumPy import random. Import matplotlib dot pyplot as plt. Import cbound as SNS. SNS.displot random.exponential. Size here we are taking 1000, and histogram we are making it as false. So we need all these modules in order to create visualization of any distribution. Okay, so NumPy, matplotlib and cbound. Obviously NumPy is for array. Okay, random is for random numbers, matplotlib is for plotting, and cbound is for distribution plot. Okay, and then here we are writing SNS.displot. We are using the same statement as we did above, only we are making histogram as false. Okay, then plt.show, we are showing the plot or the graph which has been created for it. Okay, so let's save this code and run this code. Alright, so here it is. This is exponential distribution for the size of 1000 values, and here respectively are the values. Okay, and on x-axis and on y-axis it represents the probability density. Okay, now if you talk about the relationship between the Poisson and exponential distribution, then Poisson's distribution deals with the number of occurrences of an event in a time period. Okay, how many times an event occurred in a particular duration, that is called as Poisson's distribution, whereas the exponential distribution deals with the time between the events. Okay, as I already told in the definition that once for example we got success, then we have to counter the time for the next event to get occurred. For example, it may be failure. Okay, so something like that, or it is true, then the next event if it's just waiting for to get occurred as false, so that time duration is called or is being considered under the exponential distribution. Okay, so the next distribution is chi-square. Chi-square actually it is used as a basis to verify the hypothesis. Hypothesis means, for example, you have been given a statement and we don't know about whether it is true or false. Okay, so in order to verify that hypothesis, we are using chi-square distribution. Okay, so it also has two parameters. The first one is the degree of freedom, which is defined as df, and the next one is the size, that means the shape of the array which you want to return. Okay, so let's consider a code for chi-square distribution. Okay, so we need to draw out a sample for chi-square distribution. The degree of freedom, that is df, is 2, and the size of the array which we need to return is 2 cross 3. Okay, So let's implement it here. Alright, so import NumPy as NP. From NumPy import random, x equal to random dot C-square. Okay, so we are using C-square here for the distribution. df equal to 2. Okay, so the degree of freedom is 2 and the size is 3, that means 2 rows and 3 values in each row. Okay, and then we are printing it. So let's save this code and run this code. Okay, so here it is. This is C-square distribution. Alright, now if you want to visualize C-square distribution, that means you want to plot a graph of it. So let's consider a code again. Okay, and implement it here. So import NumPy as NP. From NumPy import random, import matplotlib.py plot as PLT and import cbon as SNS. Okay, now then SNS.displot random.C-square df, that means degree of freedom is 1 and the size, sample size, we are taking it as 1000. Okay, and here we are making the histogram as false. So if you want to perform the visualization of any of the distribution, these are certainly the modules or the packages which we need to use. Okay, that's all common for all of them. And then this statement is also common, that is SNS.distplot. Okay, and then we are using random dot the distribution for which we need to perform the visualization. Here it is C-square. Okay, and then obviously the parameters which are used for the particular distribution. Okay, so here it is df and size. Okay, histogram we are making it as false, then we are plotting this distribution by plt.show. So let's save this code, run this code. Alright, so here it is. This is the distribution plot for C-square. Kindly ignore the warning that is coming for the dist plot. Okay, fine. Now the next distribution is Rayleigh distribution. So if we talk about Rayleigh distribution, basically it is used for signal processing. Okay, it is also having two parameters. The first one is the scale, and the scale represents the standard deviation actually. It decides how flat the distribution will be. Okay, and its default value is 1. And the next one is the size, obviously the shape of the array which you want to return for this distribution. Okay, so let's consider one example. Draw out a sample for Rayleigh distribution with the scale of 2 and the size 2 cross 3. Okay, so we have been given with the standard deviation. Okay, and the samples and the size of the array. Okay, now let's consider this code and implement it here. Alright, so import NumPy as NP. From NumPy import random, x equal to random dot Rayleigh, scale is equal to 2 and size 2, 3. Okay, so all these things are similar. Here we are taking the standard deviation as 2 and the size obviously 2 rows and the 3 value in each row or the 3 column. Then we are printing it. Okay, so let's save this code and run this code. So here it is. This is the 2D array for Rayleigh distribution. Okay, now if you want to visualize Rayleigh distribution, so let's consider one more code to check whether how it can be represented graphically. Okay, so implement it here. So import NumPy as NP. From NumPy import random, import matplotlib.py plot as PLT and import cbon as SNS. All these things are similar as we did above. Now SNS.displot random.Rayleigh, size, that means the sample size we are giving here as 1000 and histogram we are making it as false. Okay, so all these statements are same, just only the name of the distribution has been deferred. Okay, and then we are plotting the graph by plt.show. Okay, that means we are displaying it. Let's save this code and run this code. Alright, so here it is. It's a distribution graph for Rayleigh. Okay, that means these are respectively the values and these is respectively the probability density values for this, but all the values which have been plotted here for Rayleigh graph. Okay, now if we talk about the similarity between Rayleigh and C-square distribution, that means if we take a value of Rayleigh distribution equal to 1 as a standard deviation and 2 degrees of freedom for the C-square, then somehow what they will show a compatible graph if we just perform a comparison. So let's consider a code and then you will see how it represents. Okay, so here it is. Import NumPy as NP. From NumPy import random, import matplotlib.py plot as PLT, import cbon as SNS. Now we are performing the distribution plot for both, that means Rayleigh and C-square, and we are taking the values as, first one is SNS.displot random.Rayleigh, scale we are taking here as 1, Okay, that means standard deviation, we are taking it as 1. Size here we are again taking as, that means the 2 rows and the 3 columns, and histogram we are making it as false. And in the next statement, we are writing SNS.displot random.chi-square, okay. And here we are taking the degree of freedom as 2. Again, we are taking the same size. Histogram we are making it as false, and then we are plotting it, okay. That means we are showing the graph which is being plotted by plt.show. Okay, so let's save this code. And alright, so we can see a graph here. That means here, if we talk about the distribution of Rayleigh and chi-square, if you talk about the similarity, we are getting a very less similarity here. We are talking about that, and for the particular values of the standard deviation and the degree of freedom, we are getting certainly these kinds of graph. Okay, so there is not too much similarity here if you talk about both the distributions, but somehow what we can say that there is a bit compatibility if we talk about the area of distribution or the area of values for these two graphs. Okay, so that's all for this tutorial. We will come up with more exciting tutorials. Thanks for watching. Kindly do subscribe to my channel.